In this tutorial video, let us understand about Travelling Salesman problem and solve it using Google Colab. First, let us understand what Travelling Salesman problem is. To understand Travelling Salesman problem, let us assume we have a salesman, and basically he wants to travel to a certain set of cities. However, the restriction is that he can only visit every city exactly once, and something need to be minimized in the choice of the path that we give to the salesman. This can be in distance or travel time. Now, how this is a graph problem. This can be represented in the graph form. Let each city the man visited be the vertices, and the path he takes be the edges. While solving the Travelling Salesman problem, we need to achieve these goals. 1. Start and end at the same city. 2. Visit every city exactly once. And 3. Minimize distance covered. If we summarize what Travelling Salesman problem is, if we have a list of city and distance between cities, Travelling Salesman problem is to find out the least sum of the distance visiting all the cities only once. We will be doing the coding in Google Colab. Like we did in the previous video, we will be starting with installation of Blueqat. Type the code !pip install Blueqat in order to install Blueqat. Let us do it in Google Colab. Type the code that was shown earlier. And click on the play button to run the code. Blueqat will be installed after a while. The Blueqat is successfully installed. Next, after the installation of the Blueqat in Google Colab, let us install Python module called networkx and matplotlib.pyplot. We have to import libraries like import networkx as nx, and import matplotlib.pyplot as plt. After preparing the Blueqat, the process of importing of libraries and making of an instance is done. Let us see one example and solve it using Google Colab. If we have 4 cities A, B, C, D and we have to visit these cities once, all the cities are connected to each other with the distance value as below. We need a QUBO matrix to solve this problem on IceSing model. Now we have a cost function as this. XVJ is a binary value if visit city V on jth order. XVJ equals 1, only if city V on jth order, or else 0 if not visited. We need n squared times n square of matrix for n cities. Since we have 4 cities, so finally we need 4 times 4 matrix. Similarly we show XVJ as QI. Let's put number as ABCD cities as this. Now, to calculate the TSP we need 2 constraint term and 1 cost function. These are 1. Visit just once on every city. 2. Visit just one city on jth order. 3. Minimize the total distance. Now if we think about the constraint visit just once on every city, we have to think about just one qubit on every row will be 1, and others should be 0. For example, Q0 plus Q1 plus Q2 plus Q3 equals 1. Now, we think this on all of the row and we get this equation. Let's think about the second constraint. That is, visit just one city on jth order. Now we have to think about the column that only one qubit on every column is 1, and others should be 0. So this gives you this equation. After solving this equation, we get expanded form of the equation. Now from the expanded form of the equation, let's write it down on a QUBO matrix. This is the QUBO matrix we got. Finally, we have to think about the cost function of the total sum of distance, and we get this QUBO matrix thinking about the distance between 2 cities as Jij on the matrix. Now we need to add all of the equation and calculate. We choose the parameter b equals 0.25 and get the final QUBO matrix which is the sum of O matrix. Put the QUBO matrix in the Google Colab after all the initial installation is done. Then calculate it. Now run this code. After running the codes, let us print the answer using print function. Click on the Run button. Now from the final result, we can see the best possible solution for the salesman to visit all the city once and return back to the starting city. So, we have our final solution, And this is how the city should be visited. Thank you for watching this video.